Yes, hello. My name is Migo Jean de Dieu. I came as a teacher at College Adek Ruhanga. Now, we are going to see the Unit 1 in Senior 5 called the classification of organic compounds. Yes, you know, is prepared by Migo and presented by Migo Jean de Dieu. Yes, sir. Before I went to see this unit, let us speak on this question. Define organic compound and inorganic compound. Define homologous series and its characteristics. Differentiates organic from inorganic by using tables. State and explain clearly all classes of organic compound with examples. Describe the importance of organic compound in our daily life. End of question. And by starting with organic compound is defined as a start of compound mainly composed of carbon, hydrogen, atom, and sometimes oxygen, nitrogen, phosphorus, sulfur, and halogens. The start of these rest of elements and their compound fall under group of inorganic. Yes, the remaining one. However, there are some exceptions such as carbonate, cyanide, carbide, carbon oxide, carboxylic acid, carbon disulfide, which are such as inorganic. Yes, this is an organic. Means that organic is a compound that contains carbon, hydrogen, and sometimes oxygen, nitrogen, phosphorus, sulfur, and halogen. Apart from this, it is inorganic. Homologous series. Homologous series is a member of class of compound having similar structure. Yes, are arranged in order increasing molecular mass. They say it constitutes homologous series. Each member of such series refers as homologous of its immediate neighborhood. For example, the following sequence of straight chain of alcohol form homologous series. Here I have methyl alcohol, ethyl alcohol, propyl alcohol. This is the homologous series. A member of class compound having similar structure arranged in order of increasing masses means that here this is you have one carbon, have a 3, this you have a 2, this is arrangement increasing molecular masses. They are said homologous. Similar structures, you know, this alcohol, it is like it is here, also it is here, but there is increasing of increase of molecular mass. Here we have this one carbon 3, this 2 have 3. This is increasing, this arrangement increasing. This is homologous. This is homologous with this and this one. Homologous, first one, it is a member of this series differ from next unity. This methyl group. This is the increase of methyl group. The series mainly represented by general formula alcohol like this. This is a general formula. The common name is the general formula. This is the differ from this methyl. Also, the chemical property of member of homologous are similar chemical properties. Similar chemical property for in the some series first member show different behavior, except the first but other show semi-similar property. Also, the fourth one, physical properties such as density, melting point, and boiling point generally increasing with the molecular mass increase. As molecular mass increase, also yes, melting point and density and boiling point increase. You understand? Between organic and inorganic. First, organic form covalent. Here, form ionic. Classify alcohol, aldehyde, carboxylic acid, and it is with their characteristic. Exist as acid, base, and salt. Low melting point and boiling point. High melting point and boiling point. Soluble in water, but soluble in organic solvents, such as N-hexane, ethanol, acetone. Less soluble in water and soluble in organic. High volatile, inflammable, not volatile, and not inflammable. Reaction are very slow. Reaction is fast. Exhibit phenomena of isomerism. Exhibit very isomers, very few isomers. Why we study organic compound as a separate branch? Solution is that it is a large number of compound, breed relative few elements, unique characteristic. Yes, example, catenation, isomerism, functional group are the basis for classification, combustibility, yes, nature of reaction. This is why we study. This is a property that support that why we study organic compound as a separated branches. Of organic compound in our daily life, we use the food, example, starch, fat, protein, and vegetable. In our daily life and in day-to-day life, we find many substances and materials that are commonly used and that are later made an organic compound. Example, cloves, foods, starch, fat. cloves, cotton, wool, nail, dacron, fuel, petrol, diesel oil, and kerosene dyes, cosmetic, body lotions, soap and detergent, medicine, example this one, drugs, stationery, pencil, paper, writing ink, insecticide, yes, roadside and oil side. This is the uses of organic copper in our daily life. In industry, use in pharmaceutical, manufacture of dye, explosive and alcohol industry, soil fertilizer, petrol industry. This is the use of organic compounds in our daily life. Yes, study life process. In life process, organic in other words, in chemistry of life, for example, this vitamin, enzymes, protein, hormones are very important organic compounds produced in our body to ensure a proper development. Do you understand? Classification of organic compound is classified into three classes. Aliphatic, it is a straight chain of organic compounds. Aromatic, contain benzene. Recycled, it is arranged in form of ring. Saturated and unsaturated. You know, saturated is a single bond, where unsaturated is a double bond. You know, this is alkane, this is alkane. Yes, aliphatic example is yes, straight chain. Yes, aliphatic organic compound in which carbon arranged in straight chain or branched chain. Examples, you see examples. This is 1, 2, 3, 4. Butane, 1, 2, 3, 4. B2N, 1, 2, 3, 4. Means that we have 1, 2, 3, 4. Bit 2, yes, 3 methyl butane, B2N, B1N. Cyclic compounds, they are compounds that are caused by carbon ring. This is the ring. We say this cyclobutane. This is cyclopentane. Means that 1, 2, 3, 4, 5. We have 5 carbons like this. This is the same. And this compound that contain carbon or yes, contain one or more carbon ring that may be saturated or unsaturated. This is alkane. This is alkane. 1, 2, 3, 4, 5. This is 5 cyclopentane. Aromatic means that is compound contain with a compound that contain closed ring that contain alternating single and double bond with delocalized pi electron. This is the example like a benzene. This is a benzene. This is aromatic compound. Example, this is a toluene. This is a toluene. Methylphenyl. Phenylmethyl. Aromatic compound are designed are monocyclic, bicyclic, tricyclic, if contain 1 or 2 or 3 rings respectively. If it is 1 ring, it is monocyclic. 2 ring, it is B. This is B, it stands with 2. Cyclic. 3, it is tricyclic. Tetracyclic. Example, we have this is a monocyclic. It is a phenol. This is naphthalene. Bicyclic. This is bicyclic. Atrazine means 3. 1, 2, 3. Tricyclic. If it is heterocyclic, it is 1. We have in heterocyclic, it is the compound that contain oxygen, nitrogen, and sulfur in a ring. Example, this is 1 carbon, 1, 2, 3, 4. Furan, we call furan. Are classified as cyclic compound with include 1 or 2 atom and other than carbon. This is thiophene. Pyridines. This is S, this is N. This is oxygen. Furan, thiophene, pyridines. This is the heterocyclic. Example for heterocyclic, we have this one. 3. Of organic compound, yes. Start with formula of organic compound. In organic compound, you have empirical formula, molecular formula, structural formula. In structural formula, you have condensity, displayed, and stick, or skeleton. Yes, we are going to see. But in scenario 3, we run empirical formula, molecular formula, and structural formula. But you are going to pass through. Types of empirical formula, types of formula of organic compound. You have empirical formulas. In empirical formula, this is the question. Analyze this is the question. This we have carbon with this one, oxygen, and the remaining is hydrogen. Determine empirical formula. This is how to determine. You have a percentage. This percentage ratio of. Then you take this percentage by this one, divided with this, divided with this. In scenario 3, we run it. This is the number, the ratio. Then empirical formula come with this 3, 8. Yes, 3 oxygen. This is how to calculate empirical formula. I think that you run in senior 3. Structure formula. Determine structure formula. Structure formula show different atoms in molecular are bonded, are linked, are connected. There are 3 types of structure formula. We have a displayed, the condensed, and skeletal. We have this molecular formula. Condensed structure, it is like this. But displayed structure, it is like this. A stick or skeleton, it is like this. Here we have CH3, CH. This is the same. This you have 4 carbon, 1, 2, 3, 4. Yes, this is condensed. This is a displayed structure. This is a stick structure. Stick structure is also as considered as structure formula. Pay attention. How to calculate molecular formula? Molecular formula is a formula to express exact number of atoms of each element present in a molecular. Molecular formula is equal to empirical formula times n. This n it is equal to molecular formula divided with empirical formula. When n molecular formula is the same as empirical formula. Example: an organic compound contains this mass of carbon and this percentage, yes, of hydrogen, and this one a nitrogen, and the remaining percentage is oxygen. The remaining is oxygen. The compound has a vapor density like this. Calculate the molecular formula of compound. We are going to see percentage. Then we are going to see this the empirical formula. I think you know this one, how to calculate it. Yes. Here we have this percentage divided with this percentage of carbon, hydrogen divided with percentage, molecular formula. Yes, the atomic mass for hydrogen, for oxygen, for nitrogen. Then remaining one, I'm going to see to take atomic ratio. Take this, the smallest one, divide the, yes, to take this one divided with the smallest one. The smallest one is this one, divided with the smallest one. This is the smallest one. Yes, remain with this ratio. Have it, yes. Then you come with this 2 carbon, 5 hydrogen, 1 oxygen is 1. Yeah, I think 1 nitrogen, 2 oxygen. Yes. Vapor density is equal to half molecular mass. Then molecular mass is equal to, we have to take it 2 times vapor density. It means that we take this density multiply with 2 to have this molecular mass. Molecular mass is equal to this one. N is equal, take molecular mass, divide the empirical formulas. Then for empirical formulas, empirical mass, by using this is equal to empirical mass, it is equal to this one. Yes, try to make to find the empirical mass. It is equal to this. For n, it is equal mass over empirical mass. Take this one. It is equal to this. You have it. You have 1. Hence, the molecular formula is equal empirical formula like this. This is the empirical formula. They're the same. This is how to calculate the molecular formula. You understand? Example also, yes. How to calculate, deduce a molecular formula. We have a mass of organic compound. Combustion gave this one, mass of carbon dioxide, mass of water. If the molecular mass of acid is this one, deduce the molecular formula. Find the molecular formula. Percentage of carbon dioxide is equal to this. Take this 12 over this, multiply with this mass of carbon over this mass times 100. We found percentage. For water, take this, yes, molecular mass of, we are going to find the carbon, percentage of carbon. We take this percentage of hydrogen in water, we found this. Have to take 2 of hydrogen over, yes, mass of oxygen, of carbon, of water, of times this mass, yes, of water over this total mass times this 100. This is percentage for hydrogen. This the remaining is percentage of oxygen. This is percentage for carbon. This is percentage for hydrogen. This is percentage for oxygen. Yes, I think we have seen percentage. Then I'm going to calculate what this percentage, also this percentage of hydrogen, percentage of oxygen, then determine ratio of atom divided with atomic mass, then we remain with this one, this one, this one. Then remember, use this one. My ratio, this is the smallest one. We divide with the smallest one. It remains with this. We have 1, 1, 2. This molecular formula is this one. Molecular formula is equal to, we take a molecular, yes, mass over molecular formula. This, it is equal to 2. This molecular formula, it is equal to, molecular formula is this. Molecular formula is this one. This 2, 2, 4, oxalic acid. From the above calculation, we can extend our generalization expression like this. Formula, yes, how to calculate percentage of carbon in carbon dioxide. Take this molar mass of carbon over molar mass of carbon dioxide times mass of carbon dioxide over mass of sample times 100. This is the formula, general formula when you have mass. Also for carbon, for water, this is also general formula. For oxygen, we take this 100 minus percentage of hydrogen and carbon. Thank you for your kind attention. God bless you, dear brothers and sisters.